All right, how we doing, everybody? Doing good. All right, welcome to our PCB design class or crash course. That's what I'm calling it today. This will be recorded for everyone's reference. So, and if you have a laptop, be my guest. I will be going through the whole steps. What do you call it? EE4. Man, I've never had to write this number. 497. PCB design crash course. There we go. Wait, did I spell senior design right? Senior. There we go. Is that good? Yeah, it's okay. Anyway, so thank you all for coming today. So I'm going to be showing you guys how to practically use this. So I don't know if Hassan's given you a document. Let me show you what I have. Man, so many folders, so many things. Let's see. Oh, 320. Let's see. KiCAD. And I created this special board. Design crash course. Yeah. Sent this file out to everybody, or is this everyone's first time looking at what I'm doing?
I have not seen this.
No one's seen this? Okay, that's a problem. So it's okay. We're going to go over it. So let me show you why I'm doing this. EE Labs is that everyone here is taking 320, and the point of having that as a prerequisite is to get everyone familiar with PCB design, and that's my purpose for redesigning these labs. Here's the old PCB lab. Does this look familiar? Whatever this software was, and I don't know, you have to click through whatever this app was, and it's cool, but I went modern because this is the best way to go clean up everything up. So look at all these figures. Yeah, it's a lot. And this guide, and I'll tell Hassan to email this to everybody or give you an announcement. This will get you bare bones how to run a PCB right here, right now. It's on Canvas? Okay, perfect. And then some oscilloscopes. So I'll just be going through step by step, and you tell me if I'm wrong. So first thing you're going to do is go to KiCAD. KiCAD. Download or something like that. Download, okay? And then window or whichever operating system. If you're a Docker person, that's cool too. I use Docker as well. I'm using Windows 11. Let's go with the I think it's GitHub. I think that's what I did. Then you let it download. Don't worry, I've already downloaded it for you. Download, Windows, GitHub. Yeah, that's what I selected. So I'm going to go back here because I don't need it. I've already had it downloaded. And then let me just run this. So, I'll download, next, just hit next. I put it for me. You can also install this for your entire computer. So this is like first time setup, okay? So if you haven't downloaded KiCAD and you're trying to download it on our slow Wi-Fi, good luck. But I'm just showing you this is what you're going to see for your first time. Start with default settings, and yeah, that's pretty much it. That's a setup. So we're going to go right into it because I don't want to waste too much time. So KiCAD 9.0. There's also 8.0. Well, they're both the same. Just one of them's more, updated. So let's see what we have here. So this right here is our, what do you call it? I've been calling it like our main window, KiCAD, like main home window. This is where everything's going to be collected. And if you can see, let me show you what I've been doing. Let's see, my first KiCAD. No, this was someone else's project. Hold up. Open project, open recent. Let's see, documents. Yeah, there we go. Look what I was trying to show you. Double click on this, and you can do some cool little designs. Got some resistors. I got a mouse right here. There we go. It's better to use a KiCAD with a mouse. I'll highly recommend it because you have the middle mouse button that can move around like that. Anyways, so you'll be creating little designs like this, and let me just show you. Let me just do this. If I were to go back to our main menu, double click, this is our PCB symbol or layout view. Let it run. There we go. And I'll be showing you guys how to finally get an output like this. 3D viewer. There you go. To the point where you can finally see something 3D. So let me see. I think there was one vital step I was supposed to do. Give me a second, y'all. So tell me, how's everyone's PCB design or skill sets? What have you guys been using? KiCAD? Yeah. Has anyone heard of OrCAD? OrCAD is basically Cadence's version of PCB design. Cadence is what do you call it, an EDA company that creates various tools. There you go. There's also Altium, which I think we do have it as a university, but it's a license-based type of application, or seats. So I think we can only have 30 seats, but I haven't figured out how to assign it because you need an email to use Altium and then to check it out. It's like a library process where some manager checks it out to you and then has to forcefully take it back. So I haven't figured that out. That's why we're using KiCAD. It's easy, it's free, and you can download it on basically any software or hardware that you have. So let me do the following. So I was noting some lag. Plugged in, perfect. Okay, anyways. Let's see. If I wanted to start a new project, let's go to new project. And then I recommend you guys have a separate, like, what do you call it? Some KiCAD PCB, like, folder. This is where you're going to work. Whatever you want to do. Let me just create I don't know, EE497 KiCAD demo. There we go. Is that good? So when you create a new project, it creates two files. One of them's the, what do you call it? Schematic editor symbol. It's gonna look like this guy right here. And you got your PCB editor. That's where you start drawing your your actual layouts. The schematic editor is important. You have to know what you're trying to design. So if you have your LT Spice symbol or your schematics is all working, like let's just say you're using an op amp, or I don't know what you guys are using. We'll figure that out. So a couple things you'll probably be using is resistors. So I'll show you how to instantiate a resistor. You can either press the A button. Let's see if that A button does. There you go. A button opens up the libraries. It's loading. It takes a while to load. High details. See details. There you go. So you can either press the A button or let's see. There you go. You can press this little symbol right here. It's called place symbols. So I'm going to click it again. Okay, so the first time it needs to load everything, and then the second time it's not that hard to load everything. So if you're looking for a resistor, right? Correct? It'd be ideal to, well, just pick whatever you'd like. Any symbol matter or doesn't matter. There's various ones, like this one's a 45 degree or whatever. They're just basically notations, okay? But I think from what everyone's going to be doing here, let me see. Potentiometers, if you ever have to use a potentiometer. This is basically like your way of like drawing. Like I, as the engineer, yourself, know what's going on, but pick a symbol that's going to make sense for everybody. So here's our US representation. Does that look like a nice symbol? Or what about this one? If I were to show you this symbol, do you think this looks like a resistor? So it just depends on you. But for me, I have OCPD. I like going with what I know. It looks cool. Double click. There's a footprint right here. And some of them would have a footprint. You can assign a footprint. There's SMDs right here. You know what SMD stands for? Surface mounted device, okay? And then there's THT, through hole, okay? But right now I'm just gonna click a resistor, okay? I just need a simple resistor. Scroll wheel to zoom in, boom, you've already done it, congratulations. So if I wanted to copy paste, I'm gonna right click on it, copy, or control C. Then I'm gonna right click over here, paste, control V. And if I wanted to rotate, R to rotate, is that cool? Okay. And then if I wanted a wire, you can press, let's see, draw wires, W. It's like LT Spice. Doesn't that feel familiar? Yeah. Yeah, LT Spice is familiar. Oh, what's his name? I think there's a way for you to do a simulator. I haven't gotten the simulator yet, but you can simulate circuits on this based off whatever you feed this, like a net list. I don't think this one has a net list or anything. Pin functions. Yeah, it's okay. So I'm going to double click on this resistor, okay? This is the part that matters, is adding a footprint. This is what it's going to look like in real life if I were to click on this little stack of books right here. It's going to load a bunch of footprints. And I want to look for a resistor, okay? So it'll give you a few things. It'll give you, let me just do this, SMD, right? So if you need an SMD, this is where you'd go if you're doing very tiny designs. So there's a couple codes, and all the resistors, SMDs, always are based on codes. So 0201, 0402, and this is basically like the layout size. So this is what they'll look like. Let me see if I can show you. 3D view. Look at that. It doesn't show me the component itself, but there it is. You see that right there? That right there is an SMD, correct? So if I were to go over here, if I click on this 1608, I don't think it tells me documentation. Let's click on it and let's just see what happens. Model-wise, visualize, it's okay. But anyways, these are SMDs. So for example, if you needed, like, let's just say, I'm gonna go to DigiKey. DigiKey is gonna be your best friend, or Mauser, whichever you like. I use DigiKey all the time. And I need a, I don't know, 200 or a 220 SMD resistor, okay? Chip resistor, right? Surface mount, correct? And this is important for everyone if you're buying your components or if you have them in the lab or stock room. So let's just see. This is 1/10 of a watt, right? So you also need to know your power specifications, how much power or current you're running through your resistors. The max absolute is 1/10 of a watt, so be careful with that. So 1/10 of a watt is about, if you do IV, so if you run like, I don't know, an amp through it, you can probably run like 0.01, 10 millivolts. So be careful. That's why SMDs they're very low power devices. This one here is a 1/4 watt, just like the ones we have in the labs. All our resistors, through-hole resistors, are 1/4 watts. Actually, yeah, if you wanted to, let's go here. This is important for everybody. Your wattage. This is the standard right here. 1/4 watt that we have in all the labs. Tolerances are also another thing. The better the tolerance right here, the more expensive it's going to be. So keep that in mind. Apply all. And then, oh yeah, we have a new feature. If there's a tariff product, we can exclude tariffs, so you can buy American. That wasn't an ad. There you go. So all these don't have any tariffs. You can buy them. They're in America. All right. Or I don't know if you wanted to. If you did want tariff things, just click that button. Apply all. Let me show you this. Why is our Wi-Fi bad? There you go. Come on. Down. Tariffs may apply, so be careful when you're buying your actual parts, okay? So I don't want tariffs because I'm trying to buy it all with no complaints. Quarter watt. Let's pick this one right here. 220K. No, 220 ohm resistor. 200 to 230 ohms. I'll just give it a range. Apply. No, that's milliohms. But I'm trying to show you guys right here. Actually, maybe I'll have to show you guys the blunt force way. I don't like thinking. Let's see if this has a code. Data sheet. 1206. Is that good? Oh. Why is my laptop frying? 1206. So if I wanted to find this actual component, I'll go back to my KiCAD. Let's do 1206. There you go. Is that good with everybody? We know the exact component. I don't know what components you guys are going to be using. Double click, and then that's going to be taped to that component itself. Does that make sense with everybody? Cool. So that's this resistor right here, okay? But this resistor, I'm going to show you. Here's the footprints that we use in the labs. If you go to resistor THT, through-hole resistors, this one's easier for you guys to understand. I think the ones that we have in the lab, let me show you, are, let's see. I think it should be this. No, that's not fun. Radial power. Nope. Come on. There we go. No, that's not it. This is it. Horizontal. Let me show you what it looks like in 3D. Does that look very familiar? Okay. 6.3 millimeters in diameter, or in this length from pin to pin. Cool. And then here's a 9-1, or not 9-1. No, this is 50 millimeters, sorry. 10 millimeters, 7.62. Is that cool? And then look at the way these resistors are oriented. So just in case if you wanted to like know what you're trying to do. Okay, 207. So for just standards, I'm just gonna pick this guy right here. Horizontal. Oh, come on, computer. Oh, KiCAD crashed on me. It's okay. And it didn't save. Let me show you another thing. Let me see. I don't think it does auto save, but there's a way to get it auto saving. Let me show you. Preferences, common, auto save. Minimum times between backups is 2 minutes. There we go. Okay. Boom. Let's crash course through this. Resistor, US, boom, click, double click, okay. THT, hello, resistor, sorry, double click, no, right, come on. Why is it not letting me do my funny thing? Hello? Double click. Footprint. THT resistor. Okay. Boom. I'm looking for a horizontal. Click. Okay. Done. Does that make sense with everybody? So now let me show you what I was trying to do. Let's just say you're trying to pick this component in itself, okay? So I'm gonna go to models, okay? This is very important for any component. This is to generalize any component that you need. So DigiKey will have various types of footprints. So you may think you need to design your own footprint or your 3D model or whatever. Luckily enough, we have ChatGPT and all these other useful resources online. Someone's already made these components. So if you look through this, you already have a symbol, footprint, and 3D model, for example. Whoa, look at that. So if I go, let's go here, select download format, click this, click that, and I want to download this. Okay. So I'm downloading my component, okay? This is what I'm going to put in my schematic, right? This is what I want. Then let me see. There you go. Allow. Okay, it already did it. Let's see what it did. I need symbol, I need step, I need mod. Okay, so this one's good. Why did it download it? Okay, that one's just a step file. Okay. Delete. I'm going to cut. Let's paste this to, what do you call it? My working directory. There you go. KiCAD PCB. I created this folder called downloaded parts. You may want to as well. And then let me just paste that right there. Boom. Extract all. Let's get rid of these two numbers at the back. Hooray. Okay. Now I want to actually use this resistor, okay? So let's go over here. Let's go back to my schematic. And then one of the first things I'm going to do is go to preferences. I'm going to manage my symbol libraries, okay? And then you can already see that I've already added a few down here. To terminal block, that was something I had the students install. I'm going to click on this to add an empty row. I'm going to call this one, I don't know, my resistor something. Going to look up the folder. Let's go here. That's my resistor, right? 220K, whatever. Symbol. Okay. Then now that's there. Let me just zoom that down. Okay. Don't crash on me. There you go. Now let's do a funny button. Control S. So we don't lose our progress. Okay. Let me see if it's doing the auto backups as I want it to. There we go. Now it's doing them. Last saved. Whatever. It's okay. Anyways. So let me do another thing. I'm going to add another component. Resistor. US. Boom. Just add this right here. Okay. Double click on it. And then before I show you the footprint, yeah, when you're installing a component, I'm going to go back to our main menu, okay? I just configured a symbol library. Now I need the footprint library because we need to make sure that the library is still there. I'm going to add a thing called my resistor. There you go. Click on this folder. That's my folder. Boom. Let it do its thing. Correct. Okay. So I'm going to double click on this. Click on my footprint. Okay. Now I want to go to my library itself. So what did I call it? It's called 1206 or RC1206JR, whatever it is. RC1206. Come on. 1206. Should be here. Let me see. Preferences, footprint libraries, my resistor. Let me see. My resistor. There we go. Does that look good? Double click on it. Okay. So now our footprint and our resistor are all tied together in the schematic, okay? Does that make sense? So I'm gonna do another funny thing just to get everyone on board. Let's see, I'm gonna look up something. ESP32 IC chip, or SMD. SparkFun Electronics. Does this look like the right one? Is anybody using this one right here? ESP32. Go, let it do its thing. Is anybody using a ESP32 in here? No? Yes? Do you guys know what model you guys are trying to do? Or what chip? ESP32 6? C6. There you go. This is it. So let's go to your, actually, let's skip to the bottom. Go to models, okay? This is what you're going to be using. And look at that. Ooh, they have already done it for, you see? All the hard work's done. You just go here. This is like the ChatGPT of, like, I don't know, ICs. Download. Turn that off. I need the KiCAD. Download, okay? So now I'm gonna click here. This is you can do this for any piece you buy on DigiKey, you can do. So I'm just gonna go right into it. Let me see. Go right here. Downloaded parts. Control. Boom. Extract all. One. Extract all. Extract. Is that good? We got our symbol. We got our step. We got our mod. And I'll show you what to do with the step shortly. We got to add this. Go to preferences. Go to manage symbol libraries. Okay. I'm going to add. I'm going to call this one ESP32, or actually my ESP32, just to label something. Okay. There we go. So I'm going to go back over here. ESP32. Get the symbol. Done. Then okay it. Let it do its thing. It's just trying to rewire everything. Good. Now let's go to preferences, footprint, because we need the actual footprint now. Then let me show you. I think there's another thing I need to show you. My ESP32. Okay, click here, click here. Select folder, yes. I guess that's how it's going to work. Okay it. Cool. There's one thing I want to show you. Let me go to footprint editor just for a second, okay? Footprint editor is to actually edit the actual footprints themselves. So what I'm going to do is I'm going to go to my ESP. There it is. Double click on it. This is what it's going to look like in the PCB, okay? But what I want to try and do, so let me just see, how do I add a, what do you call it? Manage footprint library. No. Right click. Let me see. Let's see, how do I import a step file? Let's see. Look at this huge guide. PCB board, connecting footprint with 3D model. Let's see, what did I do here? Footprint properties, okay. So I'm gonna go to here, footprint properties, okay. I'm just doing something to make sure the 3D model looks good. Ah, look at that. So this is what your PCB is gonna look like. Looks cool, right? But I wanna see the actual chip, right? So I'm gonna configure file, or plus sign, there we go. Click here, This is what you do with the step file, okay? ESP32. Where'd it go? Hello? Where's our chip? ESP, come on. Oh, there we go. I clicked the wrong one. Click on dot step, okay? That's what we want, right? Dot step is our 3D file. Open. There you go. Does that look like a chip? Yeah, it looks wrong, right? So I'm gonna rotate this. Does that look better? I'm gonna move this up, offset by, let's just say, nope, wrong one. Nope. Does that look good? Bro, this chip's ugly. Let me rotate it again. Does that look better? Yeah, it's floating now. There we go. Does that look cool? So this is what your chip's gonna look like. I don't know why it's colored white, but let's just go with it. That's I guess what ChatGPT does to you. Okay it. So now it saves it. Now to save the footprint, just Control S. Okay. Now you can exit out of this guy. And now I'm gonna instantiate my actual piece. So I'm gonna go to press A. All right, and it's called my ESP32, right? Footprint not found. It's okay. We'll force it. I know what to do. Sorry. Symbol editor. Okay. I'm going to go to my ESP32. Double click. Symbol properties. I'm going to stamp this footprint. I don't think it found it, so I'm going to have to find it for him. My ESP. There you go. Okay it. Okay. Control S. There you go. Go back over here. Go press A. There you go. Now it's stamped. You like that? Did everyone follow what I was trying to do right there? So you can either do the following, which is like, okay, you have your symbol correct, and double click on it, and like keep doing the thing that I kept doing, like just kept doing footprint to footprint for every component. Or you can go straight to the actual symbol itself. So it's like if you have multiple of the same symbol, you can easily like do, what do you call it? Like attach the footprints to every symbol by just editing the symbol itself. So save the actual root symbol, okay? Or you can just do it the hard way and just go like, okay, I'm just gonna create another resistor, right? Like here's my resistor, copy, control, paste, right? Double click on it, and then I'm just gonna add a different resistor right here, okay? So it just depends on how you design it, okay? I'll make sure Hassan's, or it's already on Canvas from what everyone's told me. So anyways, double click on this, and then our 3D footprint model. Well, I'll show you. But yeah, that's how you put in a chip, okay? So whatever you're trying to do, this is what you do. So let's see. I don't know what you guys are doing with this chip, so you may have to use no connections. No connections are basically to tell the schematic, hey, when you're doing a check, I'm telling you, if I were to connect this wire like this, GPIO, general purpose input output, right? I'm telling the, what do you call it, schematic, yes, I mean to have no connection, right? So you're purposely telling KiCAD, hey, this is no connection. I purposely made that like no connection, okay? But you may need, I don't know, I'm just gonna do something funny. I need general input 1 or whatever. Oh yeah, if you want to instantiate ground, right? GND. Cool. Boom. Just creating ground. And then, what should I do here? Control R. Boom. M to move. You guys like this? No, man, this is hard. There we go. And then let me just create a flag. You can press this for label. I'm gonna call it VN, right? Oh, let's do it again. VN, it's an input, but the flag is gonna look like this. Okay. Boom. Double click, VN. There you go. Is that good with everybody? And then there's another error you guys might witness when you guys are doing, what do you call it? Your schematic design, is that you need to power your actual schematic using power flags. So this right here is an input, okay? That's something that I don't know what's gonna be. Ground is a source of power because, well, it's a reference. To add a power flag, not that one. Let me see, is this a power flag? No, I'll just show you. Go to here, place symbol, right? I'm gonna do power, okay? I think it's called power flag. There we go. You need to put this into your schematic, else your thing is gonna give you warning signs. You'll see what I mean. Okay? I'm gonna power the ground, okay? This is just to tell you that this is a source of power, because else it's gonna think the whole circuit's floating, okay? So let's do this, and then I'm just gonna call this one L for label. V out. There we go. And let's just see, and I want to delete this, whatever. Boom. Is that good with everybody? I'm just doing something very basic. Control S, Control S. So there's another thing you're gonna have to do, which is the ERC, electrical rules check. So I think this is gonna flag me for a lot of things, but let me just do this. Boom, double click. And then I'm gonna copy, paste, copy, paste. Come on, there we go. Does that look good with everybody? And let me just add a VDD. How do you power this chip? VDD. Does anyone know how to power this chip? I'm not so sure. You might have to check that out for yourself. Let me see. Schematic. Power supply. Does anyone know how to power this chip? Oh no, David, you tell me. Let's see. There's got to be a schematic here. Packaging. You'll figure that out for me, right? How do you turn this device on? Nomenclature. There we go. Is it loading? Yeah, it's not loading for me. There we go. Anyways, you're gonna have to figure out how to power this on, because I'm not so sure how to power it on. It's probably one of these guys over here. If I were to do the following, wire, double click. I'm gonna create a flag right here. I'm gonna call this one VDD 3-3 or something like that. And then this is bi-directional. Let's do that. You like that? Wire, boom. Is that good with everybody? 3.3-3. Let me just see if I can do this. I don't know if it's gonna like periods. Oh, I guess it does like periods. Cool. All right, let me just check one thing. Am I recording? Yes, I am. Is that good with everybody? Control S. Let's do an ERC. I want to see what happens. All right, this is the ERC to make sure your circuit actually works. Pins not connected. It says all these pins are not connected. Error. So you'll see right here, if it's a red arrow, that means it's not connected. See, it's saying, hey, something's going on. I don't know if that's what you meant. Okay. And then this right here is a yellow flag. Let me show you the yellow flag. Global label not connected anywhere else in the schematic. So it's probably saying the following. Sometimes when you're using a global, global flag or global label, it's expecting another schematic. You're like a book. Like if I were to do the following, let me see, file. Let me see. Root. Can I add another thing? It's okay. You guys won't have too complicated of a design. Let me show you this. If you delete this, then let me just add L for label, VDD 3.3. Okay. And then I'm going to put a power flag. A power flag. Okay. Put that guy right there because that's our power flag. I'm not so sure what will be a power flag, but you'll tell me. And I'm just going to create this one. VN. Boom. Is that good? Control S. ERC. What happened down here? Global label not connected anywhere else in the schematic. Deleted item. Let me see. It's not working the way I want it to work. Oh, Control Z. I'm going to do something weird. Connect this, copy. I'm wondering if it doesn't like it that I just have two floating pins like that. There you go. Control S, ERC, run. I guess it worked. Okay. I don't like that. Let me see. VN. Is that really what happened, or did I not run it? Hold up. Run ERC. Okay, never mind. Maybe I just didn't run it. Did I run the ERC that first time or no? I don't think I did, because now it's saying, well, VN. Okay, now it's barking at this. It's barking at this, but not that. Let's see what it's saying about this guy right here. Label not connected to anything. I have a great idea. Like that. Move. Boom. Boom. Doesn't like me. There we go. Control S. Run. Run. Okay, cool. No more barking. But you're going to have to figure this out. This is where, for the ones who are using the ESP32, be my guest, okay? But make sure once you get to this point where your electrical rules are working, you verify that every pin is forced to either something or not connected at all. Then all this should be 0, okay? So I'm going to do the next thing, which is I'm going to import this into, what do you call it? An actual schematic. Let me see. Or layout. See, I don't think it's going to show me tools. Update PCB from schematic. Okay. So I'm going to click on this button right here. All right. Update PCB. Boom. And there we go. Our 3 components that we placed in, all right? Does that look cool? Man, this is a tiny chip. So this right here is our resistor, right, from the labs. I don't have a resistor on me. But if you've seen the resistor components, right, man, this is a tiny chip. So is this what you guys are going for? Very tiny?
I'm going for very tiny.
Okay. So yeah, just be very careful. You'll have to verify that whoever your manufacturer is can actually do these actual, what do you call it, pads. But I'll show you what's going on. But anyways, this resistor right here, Let me see. I'm gonna move, double click, data sheet. Let me see. It doesn't tell me. There we go. Because remember this R2, right? If I were to go back to our, what do you call it? Switch to our schematic editor. There we go. R2 was that resistor that we just downloaded from DigiKey, okay? So whatever resistor you're trying to buy, you can find it, download it, install it, you're done, okay? That good with everybody? I'm gonna press R to rotate. And I'm gonna do the following. You see that faint blue line right there? So this is basically called a rat's nest. So if we had a whole bunch of other components, actually I'll show you. If I were to do the following, it's okay. If we had a whole bunch of other components, you'll see a bunch of blue lines, and it looks like a rat's nest. It's just a bunch of like rats just going around doing things. So I don't know how many components you guys are gonna be using, but we only have 3. So if you wanted to, it's basically a good indicator of telling you what's gonna go to where, okay? So then the next thing I'm gonna do is create a wire. So to create wires, okay, it's gonna be under track. And let me just do the following. Disturb. Predefined sizes. So here's the tough part of PCB design is you need to know who your manufacturer is going to be, all right? So the manufacturer that I use a lot, let me show you, is Oshpark, okay? This is what I use for all our senior, or not senior, our junior design, or junior classes, EE320, got the design aboard with this manufacturer. And you need to verify that, let's see, if I go to Oshpark KiCAD settings, design rules, okay? That you gotta follow all these rules right here. How many boards or how many layers you can have. You can have either 2, 4, or 6. Solder mask expansion, tent vias. And then this is what matters, okay? This is what the manufacturer cares about, okay? So let me show you. If you want to verify that those rules are imported, go here, go to board setup, okay? Constraints, all right? This is what you tell KiCAD, hey, this is my constraints, this is the manufacturer, this is what they're telling me. But let me show you what I did. That's why I made this little guide right here. If I were to go to design rules, there we go. Is this it? No. Board setup. There we go. So I already have these designs already here. Let me see. Do I punch them in there? There you go. Can you see that there? So this right here is the same as over here. Let me see. There we go. Just memorize the numbers. 6, 6, 6, 5, 25, 15. So wait. Let me show you this. This is actually in mils, okay? So here's another thing, and you're gonna be bothered by this all your when you're designing your PCB and picking out components, is that people have different standards. If you go with like some manufacturer not in America, they'll use millimeters. And if you use American, they go with mils. Mil stands for milli-inches. So 0.001 of an inch, okay? So 1 mil is 0.001 of an inch. So 1,000th of an inch. No, tens, hundred, yeah, thousandths of an inch. So I'm gonna click this button right here. This is gonna be your best friend, okay? Inches, mil, and millimeters, okay? So for now, I'm just gonna do milli-inch. This is what everyone uses. Now I'm gonna go to board setup. Okay. Was it 6, 6, 6? And what were the other numbers that I had? 5, 20, 5, 15. 5, 20, 5, 15. Is that good? And I'm getting this straight from the actual website, okay? See, 6, 6, 6, 5, 20, 5, 10. It's all just copy paste, okay? So you guys can do this with whoever manufacturer you guys are doing it with too. Oshpark's just the one that I know. I think they're based in Oregon, so that's what I went with. Holes. Let's see, what did I choose? 10 and fit 5. 10, 5. And microvias. So microvias are basically, let me show you what a microvia is. I don't think any of you guys are going to be using microvias, but it might be good to know. So top, bottom, right. Does that make sense? Then you're going to have some like middle board right here. Right? So let's just say you have your components up here, correct? All right? But you're trying to draw a tunnel going into this, okay? This right here is called a via. All right? This is an internal thing, all right? And then you're trying to draw your wire. Let me just draw it in a different color. And you're just going to draw your wire, right? And then I'll just do another tunnel. All right. And basically vias are these internal things that you're going to be using in PCBs. Most of you, I don't think, are going to be doing microvias, but this is something you are able to do if you have anything more than 2 layer, like 4 layer boards, okay? Is that good with everybody? But if you want to punch it in, be my guest. I did 20 and 10. 20, 10. Silk screen. I think I told you that you can make this whatever you want it to be. 30, 5. Okay. Is that good? So I think I'm seeing something wrong here. And let me show you what I mean. If I were to run a design rule check, DRC, right? Okay, let me just connect some wires. So if you want to create a wire, okay, click on this plus button right here. And then let me show you how big the track they gave you. So you go back here. See, do they tell you how big the wire needs to be? Minimum track width is 6 mils, okay? So that's your smallest wire. So let me do the following. 6 mils, all right? But I'm gonna add a few more. I'm gonna add 10. I'm gonna add 20. I'm gonna have, 40. I'm gonna add 80, just for an example, okay? So these are your track sizes. This is how big you can run. The manufacturer says 6 mils. Let me show you, because I think I'm panicking right now, because I think I see something funny with this guy right here. I'm not so sure. Okay. Let me see. 1 mil. Press W, or not W. Is it W? No. W to track? Nope. Route signal track, X. Okay. Hello? Come on. Okay, that's what I was worried about. Okay. No. 6, come on. Come on. There you go. It doesn't like that. Yeah. So let me tell you what's going on. To the team that's using this chip right here, Oshpark won't do your chip. these red circles right here are your actual design rules, live design rules, okay? So, and then this menu, let me show you. Draw zone fill, let me see. And it's not letting me show you. Basically, these right here are like circles of like, hey, I can't do it. It's gonna break the rules. So I was trying to draw a track right here, like a wire, but it won't let me connect it. Does that make sense? So this chip is not gonna work with the manufacturer that I picked. But if you wanted to, let me just show you. But don't do this unless you know who you're trying to talk to. Go to board setup, okay? Constraints, minimum track width. Let's do 3. Okay. Now I'm gonna do the following. I'm gonna add 3 right here. Okay. I'm not telling you to do this. I'm telling you might need a manufacturer. I don't think this manufacturer is gonna like you guys. They're gonna be like, what the heck, man? There you go. Why is it not going to it? Let's see. Board setup, constraints, copper. Okay. Minimum connection width, clearance. It's not liking this for some reason. I don't know, man. Minimum copper to hole, copper to edge. 3. Okay. Yeah, it's not liking this board right here. But point is, if you wanted to connect the wire, let me show you this. If I were to use a 20 mil track, press X. Okay, X. You can start creating your tracks like this. Does that make sense right there? Is that good? And you can tell that these are already connected, all right? But I'm telling you this, I don't know if this chip is gonna work for you guys with Oshpart. You're gonna probably have to find some other vendor that can do this type of chip right here, okay? So I think your chip has to be a little bigger, or you're gonna have to find some special precision like manufacturer that can do this. Like, look at this. This is a resistor. This is the standard resistor we have in the other lab, okay? It is a very tiny chip. So if I were to tell you this again, let me show you. Yeah, it's not gonna like this chip, but let me do something else for you. Okay. DigiKey, ESP32 IC. Yeah, sure. I'm not so sure I was gonna like this guy. Huh. ESP32 IC chip SMD. Yeah, you're gonna have to find another chip. I'm not so sure if this one's gonna work. It's just so small. IC chip. This is the one I know is gonna work. Isn't the ESP based on the ATMEGA? Is it or not? Let me just show you this one, because this one I know is going to work. So if I were to do the following, download the file, you can do this with any component, okay? Symbol, footprint, 3D model, download, okay? I need KiCAD, right? That makes sense? Let it do its thing. AU, Control X, go to our components, downloaded parts, boom. Let's delete this, extract, Boom. Symbol. Mod. Okay, we're good. And then if you wanted to, you can download the footprint too. But anyways, let me show you. Preferences, manage symbol libraries. Call this one my ATMEGA, whatever. There you go. Click on this. ATMEGA, KiCAD. I need the symbol. Is that good? Okay it. Let it do its thing. Come on. Then I gotta do footprints. And nah, let's just skip that part because I need to get something showing you. There we go. Go back to our thing. I'm gonna delete this whole chip. Boom, done, problem solved. It's called my ATMEGA. Okay, double click. Ooh, look at that, fancy. Is that good? Double click on this. Footprint. Let's see. I guess it wants me to put a footprint. Go back here. Manage footprint. My ATMEGA. Click here. Boom. Go back to my ATMEGA. KiCAD. Footprints, pretty. Yeah, sure. There we go. Okay, it. Gotta do its thing. All good. Double click. Footprint. Boom. My ATMEGA. There we go. Look at that. Which one do you like? I think these are different sizes. I'm wondering. Double click. Okay it. Then I'm just gonna control or what do you call it? Keep that there. Boom. M to move. Is there a ground over here? There you go. Wire. Boom. Is there any other pins to connect in this? And then there's another ground there. Just delete it, whatever. Control S. And then you'll have to do the ERC for yourself, but you don't have to do ERC. If you know for sure the thing is gonna work, you can just literally go to Edit, or let me show you. Tools, update PCB from schematic. Boom. Let's see. I don't want this anymore. There we go. Good riddance. Boom. That looks a lot better. I like this. See, it's a lot bigger. Okay. So let me go back to my board file. Just change back what I just did. 6, 6, 6. Now let me go to my smallest track width, 6 mils, okay? I'm trying to connect this ground, okay? Grab the wire tool, okay? Click. There you go. Now it's doing it. You see, this is what I was talking about. But this is 6. You see how this is small? Right? I'm going to double click. I like them thick, okay? So I'm going to click on this. Let me see. Properties. I'm going to make it 10. You like it? Getting thicker, huh? But I don't like doing that. I'm just gonna do the following. 20. Okay. Or actually, let me see. Use net class width. Let's try that. And it's not gonna let me do it. Screw you. X. You like that? Yeah, I like that. Boom. So for the gentleman with the ESP32. You might have to find some type of SMD that's like as big as like, you know, this ATMEGA processor right here, because it will connect. You see, you look at that. You like that? Looks nice. Okay, so now you can finally use this and whatever you need to do. Okay.
I could do that. Well, I'm using a ESP32C6 with a onboard display from Waveshare,
Okay.
and that kind of like already makes the board look like this. Like,
Oh, so you already have a PCB.
yeah.
Okay, if they're giving you like a predefined PCB, then I guess. But if you're trying to actually get the symbol, it's like the actual component, which is I think this guy right here, or what was it? Was it this? It was one of these. This guy right here, ESP32, like the actual chip itself, it's only $1.68, right? But you need to find a special manufacturer.
And that will increase the cost.
Yeah, kind of. Yeah, it depends on who's trying to do it because there's definitely a vendor out there that can do this for you. But the vendor that I'm choosing, Oshpark, that they don't do that one because it wouldn't even let me connect it. You see how now I can easily connect this one right there?
Mm-hmm.
Yeah, like if I were to bring back that symbol, you can press A here on the actual thing. If you wanted to like just dry design this with no schematic, dangerous, don't do it. But you can do this. My ESP. Look at that.
Yeah, the difference is like, especially since the ESP32 is a 32-bit versus the ATMEGA being an 8-bit.
Yeah. So what's his name? But you see what I mean? These pads are a little difficult to get to. So let me just do one more thing just to wrap this up in as best as I can. Oh, exit, exit. There we go. Control S, Control S. So you'll have to know what to do with an edge cut. Edge cuts are basically to define how big your schematic's going to be or your actual board's going to be. So let me show you what that's going to look like. Edge cuts, every manufacturer has an edge cut, how big your thing is going to look like, okay? So if you press this, I'm going to create a rectangle, okay? And it's literally as simple as just as that, okay? That's considered an edge cut. I just created an edge cut. Funny enough, there's other things. Oshpark does this funny thing where you can create your own edge cut. I don't know. I'm gonna create something funny. Hello. Is it gonna let me do my funny shape? Draw a polygon. Come on, don't lag on me. It's not gonna let me do it. Oh, there you go. Let's see. I wanted to show you guys how to. It's not gonna let me do it. Come on. Click, click, click and hold. Oh, that's cool. There we go. I'm just creating some random shape. Let me show you what it looks like in 3D. Cool shapes, right? You can do whatever you want, all right? You're not limited to just this boring old square. So if you wanted to, go ahead. I'm giving you guys these tools, all right? And then look at that. Like, see, that's your, well, you'll have to figure out your stem for that one. And that's your other resistor right there. That's where your SMD is going to go, okay? Is that good? And that's your through-hole component. Okay? Now the other thing I got to show you, and this is important, is a, what do you call it? Let me see. It's called a ground plane. And a lot of microcontrollers have this. Let me show you. Draw filled zones. Ooh, okay. Get rid of that. Hello. Let me show you. I don't think I showed you how to do it here. Top copper. There we go. Ground. Okay. So this is how you create a ground plane. So a lot of microcontrollers have this by default. Well, everyone has it. Where when you have a ground plane, let me show you this. I'll show you this on page 2. I know, PCB design. It's a lengthy process, but you can only do so much. Let's just say you're trying to design some schematic, okay? Let's make it longer, okay? And your schematic's over here, I don't know. Right, and then here's your, I don't know, chip. Right, is that good? And let's just call this one right here is ground, right? Is that good? And then there's another ground over here. All right. When you have 2-layer boards, and then, oh yeah, you're gonna have some other components too. I'm just gonna draw this right here, going through. You have another resistor right here. R, C, or something like that. Maybe this guy goes back up here. And you're gonna notice that this right here, what color should I use? Orange, I like orange. It starts looking like a capacitor, okay? All right, so there's one way we can solve this is by using a big ground plane, okay? And I'll just draw this as like, I don't know, pink. Plane, okay? And then you also have to do this to the top right here too. Okay, is that good? So that this theoretically is kind of grounded in a way, so that there's no weird capacitors. Because if you don't have a ground plane, well, I'll show you another thing. You're going to create a capacitance between the two, and it might affect your components, okay? And then there's one last thing, is capacitors are already a bad thing in the first place. We don't want to have parasitics. So what we're going to want to do is, let me just use the purple marker. You're going to create these special vias. And these special vias right here are supposed to stamp the ground plane. So in a way, we effectively short the actual capacitor. Does that make sense with what I'm trying to say right here? So the reason why, and let me show you, is we're going to always have parasitics everywhere, okay? When you're doing some type of high-speed design. And capacitors, when you have a small, like a very high frequency, right? That's very important, traveling somewhere here, there's a chance that this capacitor is going to decouple it, okay? It's going to go right into AC ground, right? So we're going to try and like minimize our ground planes, but by doing the following. So we go right here. I have a universal ground, my top copper, my bottom copper, right? Okay. And I guess I got to do my funny shape again. And just draw like this. Wonder if it's going to let me do it over. There you go. Does that work? I think it works. Press B to fill. Yay! You like that? Now let me just show you. This is the top copper right here. All right, this is all the top. So this right here is some V out. I don't know what it is. It's whatever you want to call it. This right here is your ground plane itself. So you see this right here. This is ground, right? So this ground is connected to this whole plane, all right? You also have this blue wire. This is the bottom copper, okay? If I wanted to create something, let me do something funny. If I wanted to draw wires on the back of this, I can do the following. Make sure that this is selected. And then let me do the following. Track width, X. Nope. Bottom copper, there we go. Hello, come on. Oh no, because this is an SMD, sorry. There we go. I'm gonna do the following. There we go. There we go. Something like that. See, now you can draw this. I'm gonna press B to fill again. You like that? Now I'm putting wire on the bottom side of this PCB. If you don't believe me, I'm gonna do this. View, 3D viewer. This is the top of our thing, right? That's the bottom, all right? Is everyone understanding what's going on? Okay. But now, do you see? We got this red and blue, right? And I just said that this ground plane is going to be a big capacitor, right? This right here is a capacitor, right? So we want to short this. So I'm going to do the following. I'm going to add a via, okay? This right here is your via. And you actually need to create this via. Add it right here. And then let's do following. It tells you the design rules for your minimum via size. Let me see. There where it says minimum through hole, hole to hole clearance. I think this is it right here, 5 and 20. Let me see. What did I do here? Go to my little manual. Via. There we go. What sizes did I use? I used 10 millimeters, 5. I'm using like a 2-to-1 ratio. Is that cool? Right? So I'm going to use 80 mils and 40 mils. Okay? 80. Oh. 80. 40. Is that good? Okay it. Boom. Stamp that guy right there. Is that cool with everybody? Double click on it. We have a via, right, on ground going through the top and the bottom copper. That's what we're doing right here, okay? So if you look at your, like, get a microcontroller and you're going to see these little tiny random holes. That's what they're trying to do, trying to minimize that capacitance. So if you wanted to, you can do the following. I don't know. Let me see. Copy paste, and then boom. Is that good? Boom. Copy paste, and boom. Is that good? Copy paste. Is that good? Now everything's stamped, okay? And then you can put it wherever you want it to. Copy paste, right there. Copy paste. Is that good? So now you know that that board is stamped, okay? Any questions about that? Actually, does anyone have questions, general questions, what's going on? Are you guys getting familiar with what I'm showing you here? KiCAD isn't hard. It's an art program in a way. You, the designer, the engineer, need to know what you're actually trying to do. That's why for me, I'm having a little difficulty understanding what you guys are trying to do. I'm just showing like a general like basis of like, it's just an art like it's literally an art program. That's all it is. The design comes from you. I don't know if you're doing a simple voltage divider or whatever you're trying to do, or if you're trying to use an IC chip. It just depends on how you're trying to do. Is this making sense with everybody? Any questions? No questions? Yes?
So when we're done with our design, by next semester we will have submitted to like a place where we can actually build it.
Yes, so you're gonna find a vendor, whoever your vendor is gonna be. I basically want to see like, hey, what's it looking like? Does it look good? Basically stuff like that. Because I don't know which vendor you're gonna try and do. I like Oshpart, and that's who I have. There's other vendors that do it too. I know there's some Chinese vendors out there too, but I've heard rumors that they're very cheap for a reason because they take your schematic, edit one little thing, and call it their own property. So do be wary about that if you guys are doing some special like, what do you call it, project you're trying to patent. So I use OrCAD, American-based company. So your mileage may vary. I don't know. Let me see. PCB manufacturer that does SMDs, USA. Rush PCB, JLC PCB, Green Circuits PCB. Whoa. San Francisco PCB. So you guys have many options. I don't know. Let me just check. Click right here. PCB. Let's see. Tolerances. Fabrication. Pad size. Hole size 2 mils. Ooh. Thickness of the PCB. Ooh, this is not that bad. I think I'm liking this one. Scoring. But you'll have to research this on your own. I don't know who you're trying to buy it from. Let's look at Green Circuits. Let's see. Fabrication. Request a quote. Let's go to JLC PCB. But you see what I mean? You can find other manufacturers. I just like Osh Park. It's literally all you do. Let me see. Where's Osh Park? Osh Park is you get your Gerber files. You're going to generate Gerber files for whatever you're trying to do. You just drop it in and you're done. Let me just show you. Log me in. Let me show you some other stuff. My projects. And we did some projects, PCBs, and you just drop it. And you start getting PCBs like this right then and there. Oh, these are the juniors' little designs. Pretty cute, right? So anyways, that's what you guys are going to probably be doing, okay? That makes sense with everyone? But I'm just showing you what Osh Park can do. Osh Park, I think for me, that's what works. For the gentleman, I don't know, for the ESP32, I'm not saying you can't do it, but if you can find a manufacturer that can, or whatever you're trying to do, just make sure you're understanding with whatever PCB you're trying to do that it's printable, okay? So are there any other questions? Anything you want me to show you what to do? Or actually, let me show you one last thing. Is if you want to actually generate the Gerber file, this one's a bad Gerber. You can generate Gerbers, but I'll tell you that this is not going to work. But I'm just showing you whatever. Fabrication outputs. Let me see. Let's click on it. There you go. Top copper, right? Underneath the bottom copper. Pastes if you're using SMDs. Silk screen is the actual text. And masks, cuts, not that bad. Let me show you how to add a silk screen. So if you click on F silk screen, okay, and I add text, let me see, edit, see, tools, place, draw text, my senior design project. Where is it? Yay. Like that. I'm gonna turn this one in. Does that look cool? And then let me do another one. Back silk screen. I'm gonna place text. Okay. Back board. Reversed. Is that good? So if you don't put this one, it's not going to look reversed. I'm going to put this to reverse it. Put this in, I don't know. There we go, boom. Back a board. Is that good? View, 3D viewer. Is that looking good with everybody? And you see those vias right there? Stamping both the top and the bottom plates. Okay, And then where's the back of the board? There it is. Simple, right? So KiCAD, I'm trying to tell you guys, it's not a scary program. It's PCB design is actually probably the fun part once you know what you've actually built, okay? You've tested what you're trying to do, you know it's gonna work. You're just using KiCAD to help you design something to be more compact, more permanent. You know it's gonna work. All right? All good? And then let me show you one last thing. Let me see. So now you can do text. I've had people do images. You can create a picture by going over here. Let me show you. Image converter. And then I've had people, what do you call it? I've had this already. ESP32. Downloaded parts. Where I picked the actual like UNLV logo, correct? And I'm gonna choose this guy right here. So let me do that. Load source image. Then let me do that. Is that cool? Now let me see how big it's gonna be. I'm gonna make it 1 inch long, so about this big. Or I don't know how big my board's gonna be. How big is the board? It's a better question. Let me see. Is that a ruler tool? Let me see. Tools, ruler. I can't find the ruler. Dimensions. It's not letting me tell me. Let's see. KiCAD ruler. See, using measuring tool. Where's the measuring tool? Dimension tool button on the bottom right hand. Black N with dimension arrows, or you just use the, okay. Where is that button? It's not letting me show you. Oh, that sucks. Constraint to this, constraint to that. Polar coordinates. Let me just show you, whatever. Image converter. 1 inch footprint. Top silk screen, okay. And come on. Export. Export to file. Okay. UNLV logo, I already had this already. But I'll just show you. UNLV example logo. Boom. Okay. I'm gonna add this logo right here. UNLV example logo. Is that cool? And view, 3D viewer. Oh, there's a G right there. Let me show you. Delete. View. 3D viewer. Looking better, right? So I'm just saying this, but have you guys actually started like getting your schematics all together? Your LT spices are coming together. You know what you guys are gonna be buying and preparing for this end of this semester. All right. So take your time. KiCAD is just a drawing app. That's all I can say. There's not much I can show you other than you can create vias, you can create wires, you can create little logos, put whatever you want. You can put a picture. Now let me see. Export. Let me see. Export. Control S. Fabrication output. Gerbers. I'm gonna run this DRC. It's gonna be bad. Error. It says not connected. Not connected. Net class default clearance. Okay. I see what's going on. It doesn't like this chip at all. You see that? Delete. Delete. There you go. B to fill about. There you go. Fabrication output, Gerber. Run DRC. Run it. Wow, look at that. See? And then it's just telling you warnings, okay? Track has unconnected end. Let's see. It just says, oh, this is not connected good. What is this? Text thickness is out of range. It says make it thicker. It doesn't like these texts. My senior design project. You can edit it right here. Board setup. Constraints. Text height. 30 to whatever. 20. Run DRC again. There we go. Silk screen overlap. It just says, hey, this silk screen is on top of this other guy. And then there's a star right there. Reference field. Out of range. Height. Doesn't like the height. Is that good with everybody? Gerber. Plot. There we go. And then let me see where it saved it to. KiCAD PCB. There you go. And then what you're going to need is these Gerber files, okay? See all these Gerbers? Okay. Gerber job. Gonna control X. I'm going to create a new folder. Okay. New folder. My senior design. I'm PCB. Paste. Okay. And then, before we do that, I need to generate drill files. Okay. Output folder. Right here. Dump it in there. Yeah, sure. Generate. Boom. Let's go back to my senior design. I got my drills. I got my Gerbers. Am I good? Let's go back up here. Control zip. Boom. That's my PCB. Go to Osh Park. Right here. Osh Park. And I'm going to tell you this is going to start barking, but I want to see it happen. Okay. PCB. And click and drag and you're done. Ain't that hard? Or not hard? Pretty easy. Simple. It's doing this little thing. Oh, look at that. It actually did the shape. Looks cool, right? And then for this board, I'll tell you this, with Oshpark, it's $5 per square inch. It calculated about 2.58 by 2.7. So it uses a rectangle for the area. That's, I guess, what it's doing. So for this board, 3 boards, you get 26 bucks. It's not that bad, right? You can do PCB design now. Very, very easy crash course. If you want a heart shape, be my guest. If you want a, I don't know, an Oreo shape or gear shape, whatever you like. So I'm just telling you, PCB design isn't difficult, all right? That's the whole point of why I think Hassan and I wanted to do this session. Well, I wanted to show you guys. It's not that difficult, all right? The hardest part is right now, is where you're trying to figure out if your schematics work, your designs are all good, you bought everything, you know everything works. The PCB is just a canvas to help you get everything to, like, you know, copy paste, and you're done. All right. Is everyone understanding what we're trying to do with senior design level 2 second semester? All you're doing is just plug and chug. You're done. This semester is the hardest part. All right. Any other questions? Is there anything else you guys want me to show you? Because I think I'm pretty much good to wrap it up. Is everyone good with this? So, yeah, literally the hardest part is everything you've been doing since day one of senior design is just the actual idea, the forming, like the project, your little big block diagram. There's a reason why Hassan's like going like, hey, I need this. It sounds annoying, but this is the hardest part, okay? Once everything starts formatting, like the building blocks themselves, the simulations, you know everything confidential work. The reason why you use KiCAD is to be like, I know it's gonna work. I'm ready for senior design level 2. Let me graduate. I'm gonna go home, get my degree. Any other questions? All right, so then other than that, give your board a name. Look at that, you see, and then you do this. It tells you the top of the board, the bottom of the board. Board outline looks cool. Let me see. We will cut non-rectangular board shapes, but you will be billed for the smallest rectangle that will encompass the design. So it just gave us this rectangle. So yeah, it's doing this by this. Okay, so be careful, okay? Drills, text, top solder mask, bottom, boom, boom. That's my little SMD. Is that good? And then I can order it and boom, I'm done. Okay? Cancel. Okay it. And that's pretty much it. Literally everything I showed you, this is the bare basics on how to get a PCB design done. Was this design perfect? No. This is just to tell you, hey, I can do a PCB. Technicians, well, if you're doing tech work, they don't know what the design is. The engineer, you design that schematic, that PCB, or everything. Then the tech does all the work. So KiCAD is just a way to just like throw your design and do any cool stuff. So any other questions before I wrap this up? All good? And then let's just do Control S. Close. And then there's, you're not limited to what I just talked about or whatever the manual says. You can do a lot more things. YouTube, ChatGPT, whatever resources are out there, be my guest. I recommend KiCAD. Best application you can try to do. Manufacturer, good luck on whoever you want. Or Oshpark, I recommend it. Else, all right? All good? All right, have a good day, everybody.